So C to D, -1 comma 2, and then 2 comma 0. So the question is, how much does this rise or fall for every 1 unit it moves over?
It goes up 2 and then over 3.
I think you're right on point. I'm just making my line look a little nicer there. All right, so you said up 2, so I'm just going to start. Which point are you starting at?
I started at C.
At C, which is over at 5 comma -2 right here. Okay, and you're saying up 2, and then what?
Over 1.
Over left or
Or
right?
over 3.
1, 2, 3.
Yeah.
Almost.
1, 2,
3. Oh, you know what? It's because
1,
I
2,
drew it wrong. Did I count that right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's why. My little. Just back it up here because that was one of the last things I did. There we go. So that's C, D. So you said up 2 over 3. So yep, that's up plus 2 to the right or left.
To the left.
So positive or -3.
Negative.
Okay, so we could say our slope is equal to rise over run, or our change in y, over our change in x.
Yeah.
2 divided by -3.
Oh my god, whenever there's negative, just throws me off.
The negative's a little weird.
3. Why can't I answer this question?
What is 2/3 of a dollar? How much money is that?
2/3 of a dollar? 2/3 of a dollar. I don't know, I only know like fourths of a dollar.
Right, so
Yeah.
it would be like 66 or 67 cents,
Okay.
roughly. That's what 2/3 is. It's
Yeah.
0.666666666 and so on. 1/3 is 0.33333333.
Okay.
So two-thirds is whatever. I'm just going to keep it as 2/3.
Okay.
That's fine. In fact, with slope, fractions are almost always more useful. And I'm just going to bring the negative out front, and you're going to see why this also works. You know, you went up 2 and left 3. That's fine. Whenever I do slope, I always just keep it consistent. I always move from left to right.
Oh, okay.
Okay, so when I move from left to right, let me start at like D, for example. We'll go down 2, and then to the right 3.
So it's -3, and then +3. Or -2 down.
2 down. That's our fall.
Yeah.
Or our rise, I guess. -2. Over. And then how much over?
Over 3.
Over 3.
Positive. So then you don't have to do that extra step.
Right. In this case, the negative ends up on bottom because you went left. If you always go right, you always move right, then your negative will never end up on bottom. And on top is where you get to decide, is your slope moving down, or is your slope moving upward?
Yeah.
In this case, if you put a ball right here, what would happen to it?
It'll roll down.
It would roll down.
Yeah.
It would go down 2 feet for every 3 feet it went to the right. Okay, so it's not quite falling down 2 feet over 2, down 2 over 2. It's a little flatter than that.
Yeah.
But still, I don't know, it's kind of steep. One last thing to see on a problem like this, which is totally fine to do, is let's go from D to C.
D to C.
Okay, so
Okay.
how much do we go down? And let me just lightly erase some of this here.
1, 2, 3, 4. And then, so down 4. And then 1, 2, 3, 4, 5, 6. And over 6.
Over 6.
Down 4 over 6.
Okay, so
Which makes sense because we could just double that. Or double our first one. It makes sense.
Yeah, 4/6 of a dollar
4/6 of a dollar? Oh, God.
is also the same thing as,
Oh, it's 0.6?
it's 0.666, right? Just for fun. Okay, here's 1/3, 2/3, and 3/3. Or 1/6, 2/6, 3/6, 4/6. 4/6 is the same as 2/3,
4, 6. Okay, yeah.
right?
Yeah.
Leaving behind 2/6, aka 1/3. Right? This is just a
Right.
fun little thing with fractions.
Yeah.
Basically meaning 4 compared to 6 is the same ratio as 2 compared to 3.
Yeah. My quick math is not that good.
You're fine. The fractions are honestly something that most students feel embarrassed to not admit that they don't understand at a deep level.
Yeah.
Because you learn them in like 4th grade,
Exactly, yeah.
but they don't make sense in 4th grade because you don't have like what is miles per hour when you're a kid. You can't use like real life examples that help your brain that much.
Yeah.
But then teachers in 6th grade and beyond just assume you know fractions. And I promise you there's a sea of students out there who could look at this and not intuitively really know what 4/6 means.
It's like $1 or something, yeah.
Right, exactly. And fractions are hard. Anyway, they're cool because they're relative, meaning you can do that shape, you can do this shape, or you could even do this little shape right here. Check this out. How much do you think we go down moving over 1? So this is +1 over. How much do you think we go down in that little tiny triangle?
0.5?
Point.
It's an over 1. 0.66, okay.
That's because it's
Okay,
down
yeah.
2/3 over 1. Down
Yeah.
2/3 over 1. Down 2/3 over 1. That's exactly what this. Down 2 over 3 is the same as down 2/3 over 1.
Yeah.
Well, big problem there. We just did a lot of math for one simple problem. All right, let's see. I'm going to